Hi, this is Paul again. I've got another video to show you. I'm going to call this video the new toy DNA Metro. Now I got this idea from my last video of a 3D printed ICOSA with a Duo Phi vector system. I realized after I put the video out on YouTube that we basically had a coordinate system. And I showed in my previous videos that this coordinate system was used by the ancient Celts for Stonehenge, and they used a bronze dodeca that have been found in Europe. You can see that this is obviously used for the Duo Phi coordinate system. Now, not only did the Celts know about this system, the ancient Egyptians used this system also. Now let's look at the geometry of the Great Pyramid. It has been discovered in the last few years that the 4 faces of the pyramids are actually split to make up 8 faces. Now you can see that the 3D geometry of this Phi coordinate system solves that question, because you can see that the rectangular planes lines up to the faces and edges perfectly. Now look at this geometry again. It can produce the Maltese cross. We can also find this cross in the Celtic cross and the Egyptian cross. But this geometry basically shows us the Duo Phi vector system. And in front I show the rectangles from this cross are interrelated with perfect Phi geometry. Now look what you can do with this Celtic geometry. First, it can give us beautiful 3-phase sine waves, and it also can give us sound waves. You can see that these vectors produce 6 sound waves around the center red and yellow vector. It can also produce delta waves. It's shown as a little toy that can be 3D printed. I have showed in my earlier videos that DNA nucleosomes and DNA can come out of this vector system. And this can also be turned into a little toy and 3D printed. So this is why I really think this Duo Phi vector coordinate system is very important. Because I think life form with DNA and stuff like that and diseases are all based around these vectors. Now let's look at the system that everybody works with today. You can see that the X, Y and Z vectors are only based around the faces of the cube. Now let's look at one cube in the Duo Phi vector system. Now you can see that that yellow cube is aligned to 8 vectors, not just 6 vectors. Now I'll bring in a red cube, our second cube. Now you can see that this cube lines up with the red and yellow vector, and the cubes are golden ratio to each other. Now let's show a yellow and green cube. And you can see that the yellow and green cubes are rotated golden ratio to each other about the yellow and green vector. Okay, now we'll do the same with the yellow and cyan cubes. And now you can see that the yellow and cyan cubes are rotated about the yellow and cyan vector at golden ratio. Now I'll show you the purple and yellow cubes. And this works out exactly the same golden ratio around the yellow and purple vector. So now you can see you can pick any one color and golden ratio dual it with the 4 other colors. Now look at each face of the dodeca. You can see the edges of 5 colored cubes. Now these edges can be spherified. I showed this in a video I put out in March 31st, 2014. The name of the video was the 369 Non-Chaos Metro. Now each cube produced 6 geodesic lines around the sphere. If you look closely at each vector, you see the colors of the cubes. 12 of them are from 2 cubes on each vertex. I found that you could go from one vertex to another just like metro stations. Found it would go 147 258,369 10 times around the sphere. Anyways, I've decided to turn it into a little toy on my 3D printer. Now I made the geodesic lines of the cubes into grooves so that they could use colored pens to put the colors. Let's see what I've come up with. There are a total of 12 pentagon shells. 8 shells show a double vertex connector. 4 shells only use a single connector. This is a big improvement in design to my last video. Now you can see that the dodeca vertices are 2 colored plastic washers. They can 3D print very easy. And the same goes for the little pentagon for the vertex of the icosa. The 2 hub shell takes about 6.5 hours. The single hub shell takes about 4 hours. The bolts are 632 by 1 inch. I show how it goes together in this video. It's pretty straightforward. You see, I've numbered the single shells and the double shells. Okay, I'm going to start with the D2 shell, and now we'll give it a D1 shell. Now for an S1 shell. Now for an S4 shell. Now for a D3 shell. And now for a D6 shell. Okay, so that's the 6 shells on the front, so we'll rotate it around and then we'll do the other 6 shells. Okay, we'll start this one with a D4 shell. Okay, so this one starts with D4, then we go to D8, then we go to S2, then we go to D5, and then we go to D7, and lastly S3. Okay, we can check with the vectors. Everything seems to look okay. I hope so. Now I'm going to show you what the real thing looks like. I have used one of them washable markers from Crayola, and I've put a red line between the red vertices just to show you. Now if you look at my old video, the 369 DNA Metro, I show that there are sequences 147, 258, 369 going 10 times around this sphere. It's just like a 3D processor. It seems to be a 100 process using 10 systems of 10. This is a very nice educational toy because this is a lot of uncharted territory. Very few people are looking at this sort of thing in 3 dimensions. It's possible to do them grooves with these texture 3D paint programs. Anyways, I'm going to call it a day now. So this is Paul saying thank you very much for watching my video.